Welcome back. This is Mrs. Rubright with Advanced Geometry, and today's lesson is 2.6, Proof Statements about Segments and Angles. All right, so just like the problem yesterday, this is the same problem as yesterday, we're just going to do it again. Write a two-column proof for the situation in example 4 from lesson 2.5. So we have our given and we have what we're trying to prove. So the first thing we're going to do is we're going to make the lines for our statements and reasons. Make our two-column proof. So we have our statements and we have our reasons. All right, so number 1. Given that the measure of angle 1 equals the measure of angle 3, given that the measure of angle 1 equals the measure of angle 3, so we're going to write that down, and our reason is given. All right, so what are we trying to prove? We're trying to prove that this whole big angle here equals this whole big angle there. And we know that because we know that these two are equal. And if these two are equal and this is a shared angle, then obviously 1 plus 2 equals 2 plus 3 because the 2 is in common. But we can't just say that. We actually have to prove it. So what we need to do is we can look at this proof statement and we can say that the measure of angle EBA equals the measure of angle EBA, 2 and 3. 2 plus 3. Angle addition postulate. Same thing for DBC. So the measure of angle DBC is 1 and 2. So we're going to line those 2's up. And we can see, okay, these are the same. These need to be the same. Well, 1 and 3 are the same. So I can plug in a 1 in for this 3 right here. So my next line, this is also angle addition postulate. My next line can be the measure of angle EBA equals the measure of angle 2 plus the measure of angle 1. And I did that with substitution. So now, hopefully you see that these are exactly the same. They're the same because I had subbed this 1 in for this 3, right? So now they're the same. Since they're the same, we can do sub a whole side for a whole side, transitive property. So I can take this right here and plug it into this side. So I would have the measure of angle EBA, I'm writing it exactly like they want the proof statement written, equals the measure of angle DBC, transitive property, as you're subbing a whole side for a whole side. And that is your entire proof. This is a geometric proof, which you guys don't love. I know the algebraic ones are a lot easier, but you'll start to get the hang of these, and they're really not that bad. Start with your givens. Then what else do I know? There has to be something else that I know. Is it segment addition? Is it angle addition? What else do I know? What have I learned so far? And then you kind of just go with that until you see how to get to that proof statement. And sometimes looking at where you need to get to can help you figure out how to get there. So you can always work your way backwards too. All right, so 4 steps of a proof are shown. Give the reasons for the last 2 steps. All right, so this is our given. So we always start with our given, and the reason is that it's given. Our proof statement will always be the last thing, right? So let's see what's going on here. So they said that AC, the whole thing, is AB plus AB. They're saying that this plus this is the whole thing. So my brain is telling me that, well, that means that these two are equal, but I need to prove that. So what I can say is my segment addition postulate. AC is AB plus BC, right? Part plus part equals whole. Segment addition postulate. Now looking at these two, do you guys see how they're both set equal to the same thing? Transitive property, set them equal to each other. Sub a whole side for a whole side. So now when they're equal to each other, do you guys see that there's something that's on both sides? So can't I subtract it and it's gone? If I subtract it here and when I do to one side, I must do to the other, it'll be gone, right? So I can subtract it out on both sides, leaving me with AB equals BC, which is what I want. So that's the subtraction property of equality. They got rid of the AB by subtracting it on both sides. Does that make sense? Some of you might have done this in 2 more steps. You could have added these together. 2AB equals AB plus BC, and that would be simplify. And then you could divide by 2 on both sides, right? Or not divide by 2, but nah, because it won't get you to here. It'll look ugly unless you divide it by AB on both sides, which would bring you back to here. It's just extra steps. But yeah, I mean, you can just, anytime that there's duplicate stuff on both sides, you can just subtract that out or add it out if it's negative. Name the property illustrated by the statement. So if angle A is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. So what is it saying? This is like if A equals B and B equals C, then A equals C. Get rid of our middleman. Subbing a whole side for a whole side. Transitive. This is dealing with angles and they're congruent. So transitive property of angle congruence. See how they do that? Get it? Transitive property of angle congruence because you're talking about congruent angles. How about this one? Yes. So he thinks it's symmetric. This is like if A is if A equals B, then B equals A. Flip flop. So he's saying flip-flop is symmetric, and this is dealing with segment congruence, symmetric property of segment congruence. CD, segment CD is congruent to segment CD. Yes? Yes? Reflexive, good. The reflexive property, same thing, and this is of congruence. Same thing equaling the same thing, or same thing being congruent to the same thing is reflexive property. Angle Q is congruent to angle V, then angle V is congruent to angle Q. Flip-flop, yeah? Reflexive property of angle congruence. Wait, did I just say reflexive? Yeah. Reflexive is same thing, same thing. Sorry, symmetric. Flip-flop is your symmetric. Symmetric property of angle congruence. Symmetric. Symmetric is when you solved something for x, but then you want the x on the left side and you just flip-flop the equation. Prove this property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 of AB. I can't really move it. Kind of wanted to move it out of my way, but oh well. I'll just try to write small. Statements, reasons. M is the midpoint of AB, given. All right, so what do we know? Anytime that we are given a vocabulary word, the next line is what we know because of the vocabulary word, and the reason is the definition of the vocabulary word. So what does midpoint mean? Midpoint means it breaks it into 2 equal segments. So that's telling us that AM is congruent to, or is equal to, right? AM equals MB. Definition of midpoint. Okay, yeah, I was right. So midpoint actually says that they're congruent, right? Midpoint tells you that the two segments are congruent, right? So then you have to change it out of a congruent symbol into an equal symbol because everything's dealing in equal. So now you're just going to go AM equals MB. And that reason is definition of congruent segments. If they're congruent, then they're equal. All right, so I'm trying to get to AB, the whole thing equaling 2 times AM. So if I'm trying to get to the whole thing equaling something, why don't I do like a segment addition thing, right? Can't I do that? Can I say that the whole thing, AB, equals AM plus MB, segment addition? Postulate. All right, so now let's look at what I have. I have AB equals AM plus MB. I want it to be 2 times AM. So I want this MB to be an AM. Can I do that? Right here. Substitution. AB equals AM plus AM. Substitution. So you guys see how I keep going to what I'm trying to prove to see what to do next? Well, AM plus AM, isn't that 2 AM? Simplify, right? So they call it distributive property. It's kind of like simplifying, but they call it distributive property because it's like the reverse distributive property, right? So anytime like you're kind of doing like the reverse of distributive property, they call it distributive property. And so that's our A, okay? Now to get to B, what do I have to do to this to get here? So I want AM to be solved, and I need to get rid of, so all I'm going to do is divide by 2 on both sides, right? And I would have AB, or 1/2 AB, right, equals AM. And how did I do that? I just multiplied by 1/2 on both sides, or divided by 2, right? So that's your division property of equality, because you divide by 2 on both sides. And then the last thing would be here. This would be step 8. And step 8 is just flip-flop, which is going to be the symmetric property, right? Because all I did was I just flipped it so that it's AM on the left. Make sense? That's it. Oh, I gave myself more room on the next page. That would have been nice. And there it is. Okay. Nice and neat. And that was your entire lesson. So I hope you guys enjoyed your lesson on 2.6. Prove statements about segments and angles. Like and subscribe and have a great day.